What's up? Welcome to 1.6 Function Operations and Composition of Functions. Look what I did with fun. We're having fun. I'm so clever. All right, so we're going to be playing with functions pretty much this whole section. Not a ton to it, so two things we'll be doing. The first thing is adding, subtracting, multiplying, dividing two different functions. Pretty straightforward. If it's written like this, you're just going to straight up add the functions. Okay? If I'm asking you to do this, you're adding, asking you to do this, subtracting, so on and so forth. So we're going to do an example down below, and I wrote you two functions. F of x is equal to x minus 4, and g of x is equal to the square root of 9 minus x squared. And we're going to do all four operations, sum, difference, product, quotient, and then state the domain of each. All right, so let's do it. We got first addition. Simply just write it as x minus 4 plus the square root of 9 minus x squared. There's nothing more to simplify with this at all. But we're going to write the domain. And we have a square root, so I'm sure you know how this rolls. Isolate x, add x squared. X squared is less than or equal to 9. Square root both sides, you're going to get 3 is greater than or equal to x, and then we also have to flip both signs. We've got 3 is greater than or equal to x, and negative 3 is less than or equal to x, which is written, it's a bit in betweener, that's negative 3 to 3. It's bracket, so that's going to be the domain for that first one. Next, x minus 4, parentheses, minus square root of 9 minus x squared. Domain's the same. We have the same function there, so it's not going to change. Next, we have x minus 4 times the square root of 9 minus x squared. It would be nice if we distributed square root of 9 minus x squared, simplify it a little bit, so we x, it looks like y, there, x times 9 minus x squared minus 4 square root of 9 minus x squared. And that can't be simplified anymore, but it also has the same domain, which is bracket negative 3, comma 3. Now we have f of x divided by g of x, so it's going to be x minus 4 over the square root of 9 minus x squared. Now is it the same domain? It is not, because the denominator cannot be 0, so we just make one adjustment. It will be parentheses negative 3, comma 3. Now it's time for composition of functions, the second thing we're going to do today. So you might have also shortened composite functions, right? They pretty much are functions within a function, okay? So we're going to do some examples right away, and we're going to do 3 right below here. We're going to find, and this is how we read it. It's f of g of x, g of f of x, and then f of g of 3. Okay, you might have seen these written like this. Okay, maybe that rings more of a bell. Either way, you could see either or on your ACT, SAT, etc., etc. So this is essentially what we're finding. Now this looks daunting and confusing, but it's really not, okay? Because what you're going to do is you're going to take the first one, the g of x function. This is the g of x function here, right? 5 minus x squared. You're going to take 5 minus x squared and put it everywhere you see an x in the f of x. Okay, so you work right to left. So take the g of x function, put it into x everywhere you see an x in the f of x. So if f of x is equal to 3x plus 1, instead of x, you're going to put in 5 minus x squared in for x and plus 1. Simplify, you got 15, not 10, 15 15 minus 3x squared plus 1. Simplify, you get negative 3x squared plus 16. And that is f of g of x is equal to negative 3x squared plus 16. Now it's the other way around. So it's g of f of x, put in f of x, and then everywhere you see x in the g of x function, put in f of x. So it'll be, instead of 5 minus x squared, it'll be 5 minus parenthesis 3x plus 1 squared. If you FOIL out 3x plus 1, you will get 9x squared plus 6x plus 1. Distribute the negative sign, you get 5 minus 9x squared plus, excuse me, not plus, minus, because I distribute the negative sign. So minus 6x minus 1. Like terms will get us negative 9x squared minus 6x plus 4 would be your answer. And finally, f of g of 3. In my opinion, these are easier because what I'm going to do is work from inside out. Meaning, inside I have g of 3, right? So I'm going to find what g of 3 is first, which is going to be 5 minus 3 squared. 3 squared is 9. 5 minus 9 is negative 4. So g of 3 is equal to negative 4. So I'm going to substitute that in for g of 3, and then I'm going to now find f of negative 4. F of negative 4 is going to be 3 times negative 4 plus 1, which is going to be equal to negative 11. So your solution is negative 11. For these two problems, I'm just going to do f of g of x, and they're kind of special cases in their own right, and something I want you to see for either one of these. For f of g of x, for this left problem on the left, so I'm taking the g of x function and putting it in for x. So it's going to give us a square root of x squared minus 1 plus 1. Ones cancel, left with a square root of x squared, which is equal to x. Now let's reason with this a little bit because the answer is not just x. I know it logically seems like it should be x, because the square root of x squared is x, but for this function right here, for this part right here, if we put a value into that, let's say we put, well, whatever value you want, that makes the square root negative, it won't exist, right? And if we get to this point right here, x could be negative, right? So it can only be positive value, so it has to be the absolute value of x. So to reiterate, remember, if you find a square root of x squared, even power, even root with an odd result, you always have to put absolute values when you do that, okay? Because if I put in negative 2 squared is 4, 4 squared root of 4 is 2, right? As opposed to writing just with x, that's not equal to negative 2. So you have to put absolute values in this case. Now, let's do the other one, f of g of x. So I'm going to put in x squared plus x into this. So it's going to be 5 over x squared plus x. And we need to write a little domain, right? Because there's values that it's not going to work, right? For the original, it might work for some values, but now it doesn't. So it's going to be all numbers except for what? What makes the denominator 0? 0 and 1. Excuse me, 0 and negative 1. Don't believe me? Factor by using the GCF. And then, so x can't be 0 and 1, negative 1. Keep wanting to say 1, it's negative 1. And then if we write it in integral notation, negative infinity to negative 1, negative 1 to 0, 0 to infinity. All right, so let's decompose a composite function. What does that mean? So I'm giving you this h of x function, and what I want is two functions that we can use as composite functions that would equal this. If you are in regular pre-calc, You don't need to watch this. We're not. You don't have to do this. But for those of you in honors, stick around. So one thing I notice and look for. So there's two things, strategies. Okay. One is that we're going to need a factor. There's no factoring with this problem. You can't factor 1 over x plus 7. Second thing is, let's recognize what type of function this is. This is a rational function, right? It's 1 over a number. It's rational, okay? So that tells me that probably 1 over x should be involved with this in some way, right? That original function, 1 over x, is usually going to be what we're putting into something, right? So we're going to call that what f of x is, right? And then g of x is what? Well, it has to be whatever we are going to be putting in and what to our denominator. That's going to be x plus 7, right? So your answer is going to be g of x equals x plus 7. All right, and that is everything. Appreciate you watching, and thanks for stopping by. Bye-bye.